Guys, welcome to today's class. Before now, we've been doing with on circle geometry. We've looked at several things on circle geometry. We've considered what a circle is, the collection of all points that are equidistant from a central position. We've looked at components of a circle, which are radius, circumference, chord, sector, segment, diameter, and every other thing that has to do with a circle. We have also looked at how to calculate the area of a circle, area of a sector. We have also looked at how to calculate the length of a chord. We have also looked at how to calculate the length of the circumference of a circle. We also looked at how to calculate the length of an arc. We have done several things on circle, and today we are going to be moving over to circle theorem. So what is circle theorem? Circle theorem actually focuses on the behavior of angles within a circle, the behaviors of angles within a circle. And now it is very, very important that we start with this first theorem, because many other theorems we'll be dealing on will be based on this first theorem. That means if you really understand this first theorem, you will not have any issue with circle theorems at all. If you can understand this first theorem, you will not have any issue with circle theorems at all. So what does this first theorem say? The first theorem says that the angle at the center of a circle is twice the angle at the circumference subtended by the same chord. That looks like a jargon. Let me explain. Now, in this circle, we have 3 points on the circumference. We have A, we have B, and we have C. Also, we have 1 point and center, which we call O. Is that okay? We call it O. That is the center of the circle. So we have A, B, C, and we have O. Now, there's something I want you to understand. Whenever you have 2 points on a circle, there's actually a chord there. It may not be visible, but what I just want you to understand is this point A and B, I can actually draw an imaginary line and join it. That will form what? Chord AB. Is that okay? That will form chord AB. So, but the way I leave it, it's actually not showing. Or the way we have it, it's not actually showing. Also, the way we have A and C, you see there's a chord there. Anytime you have 2 points, any straight line that joins those 2 points is called a chord. So, although we don't have a straight line here, I just want you to understand there's an invisible chord here. And because this chord hosts an angle at the circumference, right? That same chord hosts another angle or subtend another angle at the center. Let's say this chord AB, this is the same point. You see, where A is the same point, If you go to circumference, there's an angle is subtends at the circumference, and that same point, 2 points, subtends an angle at the center. So what this first theorem says is that whatever angle you have at this, so far it is this same chord or this same arc, is the same thing that sustains angle at the circumference and also subtends another angle at the center. Now whatever you have, whatever angle, the magnitude of the angle you have at the circumference will be half of the angle you have at the center. That means what you have at the center will be 2 times of what you have at the circumference. Meaning that if I have 50 degrees on the circumference, at the center I'll be having what? I'll be having 100 degrees. Also, if I have x degree at the center or the circumference, I'll be having 2x degrees. Is that okay? So if I have whatever I have, if I have 30 degrees here, that means here will be 60 degrees. So what we're going to do now is that I'm going to prove this theorem to you so that you see that it actually works like that. And then I'm going to solve one example. Is that okay? So let's go about it. Let me draw a circle. Let me just repeat what we have. Let me make this one very big, very diverse. Let's say this is C, this is still our A, and this is our B. Now let me have a chord, or rather, let me just leave the chord. Let me say this is the center of the circle, and that same point subtends another angle at the center. Is that okay? So what we want to prove now is that whatever angle we have here, the angle we have here will be times 2 of it. Let's say, but before we go on, I want to split this triangle, or rather, this is actually a quadrilateral. It has 4 sides, right? 1, 2, 3. But I want you to pay attention. This and this are all radius. This is a radius going from the center to the circumference. This is also a radius going from center to circumference. This is a chord, and this is also a chord. Is that okay? Now I want to do something. I want to split this shape into 2. Let me say I want to split it into 2 equal parts. Let me use an imaginary line to split it into 2 equal parts, such that I can have A here and I can have B here. Is that okay? Let's say I have A degrees here, I also have B degrees here. Is that okay? This is A degrees, this is B degrees. Now, looking at this triangle, we discover that, let me bring out this part. I have something like this. Right? Yes, I have something like this. Now, if you look at it, let me say this is my A. Let me also bring out the other part. I have something like this. Let me say this is my B. Now, looking at this now, because this is, do you know that this imaginary line I drew from here to here is also a radius, because it goes from the center to the circumference. So that is the point here. That means here is a radius, here is also a radius. That means these 2 parts are equal. Also, here is a radius and here is also a radius, meaning that these are both isosceles triangle. If they are isosceles triangle and here is A degrees, that means here is also A degrees. Is that okay? Now, if this is B degrees, that means here is also B degrees. I just want you to follow me. If this is B degrees, this is also B degrees. If this is A degrees, this is also A degrees. Now, remember, this line, when I drew it, I kind of extended it a bit, right? That's also what we have here. I kind of extended this line a bit. I knowingly did that. Now, the total angle in a triangle is 180 degrees. It means that if I have A degrees plus A degrees, let me say here I have, just choose any number. Let's just say here I have, let's say P, right? So A degrees plus P degrees will give me 180 degrees. That is the total angle in a triangle. Also, B degrees plus B degree, let's say I have Q here, will also give me 180 degrees. But on the other hand also, I want you to also notice that this is actually a straight line. This is actually a straight line. That means here plus here will also give me 180 degrees. Is that okay? Here plus here will also give me 180 degrees. Let me call this one. You can call this anything you want to call it. Also, here plus here will also give me, everything here will also give me 180 degrees, and everything here will also give me 180 degrees. So if this plus this plus this will give me 180 degrees, also, and this plus this will give me 180 degrees. That means 2A plus P will give me 180 degrees. Let me just show you. If I have that 2A plus P will give me 180 degrees, and I also have that P plus, I can call this Y and I can call this Z just for this lesson's sake. Is that okay? And I also have that P plus Z will give me equal to, or rather Y will give me equal to 180 degrees. What it means is that this my 2A is the same thing as Y. Is that okay? Because 2A plus P will give me 180. Also, P from Y will give me also 180. That means this 2A is the same thing as Y. Meaning that whatever I have here, if this is A, this will also be A. Whatever I have here, what? 2A. Is that okay? Now, coming over to the other side, I have B here, I also have B here. If I have that 2B plus whatever I have here, which is Q, is equal to 180 degrees, and also have that Q plus Z will give me 180 degrees. What does it mean? It means that these 2B and Z are the same thing, because this is Q and this is Q, right? So this place will give me what? 2B. Is that okay? So I have B at the circumference of the circle. I have A plus B, right? I'm going to clean this. At the circumference of the circle, I have A. At the circumference, I have A plus B, while at the center, I have, this is circumference, I have A plus B, while at the center, I have 2A plus 2B. If I factor out 2, I'll have 2 brackets A plus B. So whatever I have here, if we call, let A plus B equal to X. So I have that what I have at the center will give me X, and what I have at the circumference will give me what? 2X. So this proves that whatever we have at this, whatever this arc or chord suspends at the center is actually half of what it suspends at the circumference. Having understood this now, I'm going to give you some, let me just solve one question before we move on. I'm going to solve one question here before we move on. Let's say you have a question like this. This is center. Let's say I have 60 degrees here, and you are asked what angle this question can come in any way, right? It can really come in any way. They can ask you, okay, what angle is at the, does this arc sustain at the circumference? If this is 60, it means that it sustains 30 degrees here. Is that okay? If this is 60, it sustains 30 degrees here. Is that okay? Let me give you another question. This may be a bit tricky. If I have 60 degrees here, I am told to find the angle here. Let's say we have angle X here. What will this angle X be? What will this angle X be? Remember, I can choose to split this into 2. Everything here will give me 30 degrees, which is half of what we have here, right? If I split into 2, it will give me 15 here and 15 here, right? Now remember, this is an isosceles triangle, so if it gives me 15 here, this one will also be 15 degrees. So you can actually use this concept to solve a lot of things in circle theorem. Tomorrow we'll continue from where we stopped today, and you're going to see how many more things we can do with the knowledge of this theory. Make sure you do your assignment and tell your friends about the class. Have a nice day.